Cool. Thanks, Bill. Yeah, so like Bill said, my name is Dan Phillips, Daniel Phillips. And today I'm going to talk to you about WebAssembly and using it with React and with JavaScript in general. So um, with that, just a little bit about me before we get started. And like Bill said, if you want to drop questions in the chat in the meantime, feel free. I'll try to notice them as we go forward here. So I'm a software engineer at a startup called Loophole Labs, where we do quite a bit of infrastructure work. I focus mostly on WebAssembly. That's actually server-side WebAssembly right now. And there's a lot of overlap, though, with server-side WebAssembly and client-side. I do a lot of work with Rust and Golang, JavaScript, some things in that area. And I'll talk a little bit more about what we do in that arena a little bit later. I've been a huge fan of Wasm, Wasm. The pronunciation, people can debate it, but maybe technically it would be Wasm because it kind of comes from the precursor ASM.js, which was sort of, I'll also touch on that here in a second too. But I got more into it in 2018 after there was a few things that came out that people had made with it, and it was getting more standardized in browsers. And in 2021, I started the WebAssembly Chicago meetup group. So that's wasmchicago.org. It's very similar to React Chicago, just with not as many people involved because it's a little bit more focused on some smaller things happening in WebAssembly that are still developing. But we do all of our stuff online, so you can check it out if you want. We're also on Meetup. You can always drop me a line if you're interested in coming to speak or just want to show up. And full disclosure, I'm not really a super great React dev. I've definitely done a lot of work in JavaScript, probably more in Vue than in React, but I've definitely done some work in React, and I've done work with Vanilla.js and like jQuery even, and I've also worked in Node on the back end too. So I do have some production experience with JavaScript. Cool. So I'm going to talk about WebAssembly. And just to get this started, probably if you're here, if you were curious about this talk, you might have heard of WebAssembly and you might be wondering what it is, or maybe you're wondering like why it's taking so long, if it's the future, like everyone's saying. So I kind of wanted to bring this up as sort of something to start with, and then we can get more into this as we get going. So it wouldn't really be a tech talk unless I reference one of my own tweets. So here's a tweet from last February, actually, the same day. Well, that's wild. February 22nd, 2022. That's insane. That's from a year ago exactly. And I tweeted this out, and sort of my goal with this talk is to sort of show you why I think this is actually the case and not just hyperbole. So yeah, if you work in any of these areas, front end, back end, web dev, infra, mobile, crypto, ML, Internet of Things, et cetera, there's a good chance that you will come in contact with WebAssembly soon if you haven't already, and you'll at least hear about it and maybe hear about it more in many contexts. And we'll talk about why. So what is WebAssembly? WebAssembly, WASM, doesn't really matter. WebAssembly is this is right from the spec itself. It's a safe, portable, low-level code format that is designed for efficient execution and compact representation. Okay, so what does that actually mean? Well, what that actually means is that WebAssembly is a safe sandbox and execution environment. It makes no assumption about language or host. Okay, still doesn't quite explain what we mean. The best way to think about it, I think, is to think about it like a virtual CPU, right? It's a virtual instruction set architecture, an ISA. So basically, you can, but you typically don't write things in WebAssembly itself, right? You compile things to WebAssembly, right? And so one of the things that you might have heard of is Rust. Rust has first-class support for WebAssembly, where you can write things in Rust. You can compile it to WebAssembly, which is just like compiling it to x86 or something like a native architecture. If you want to run your Rust binary on your machine. Okay, so just like you compile it to a machine instruction set architecture, you can compile it to WebAssembly, which is very similar to a real instruction set architecture with a virtualized layer that is the WebAssembly runtime. So what that all means, I'll kind of get into more here too. So if you're at this meetup, you might have heard this too, like WebAssembly is the future. Too long didn't read. No, it's not going to replace client-side JavaScript anytime soon, if ever, actually. And one of the reasons why is like I was saying, because it is it's really just like a set. It's like an ISA, an instruction set architecture. So it really doesn't have a place right now in building UIs, right? So if you've ever heard of Dan Abramov, who's a big guy in the React community, I'm sure you've many people, if not everyone here, knows him. He has this great piece called React as a UI runtime. It's a really great blog post. And you can kind of think of WebAssembly as the complement to that, as WASM is a compute runtime. Okay, so JavaScript will always be there for working with building a view layer, but WebAssembly can do some things that JavaScript maybe isn't so great at for things that are more compute intensive. Okay, so another point here is that more and more things will be built and ported to WASM in the browser. I'll give some examples of this, but now is a really good time to sort of be watching for that and seeing how it develops. Interop with JavaScript will get better. It's currently being worked on. So interop meaning how to get data in and out of WebAssembly from the JavaScript runtime to the WebAssembly runtime, because these are separate sort of entities that will both need access to the data that you're trying to work with. Now's a great time to start following along, right? That's kind of the sort of crux of this whole thing. And I'm sure you've been to other talks about this. Other people might have said the same thing over the last few years, and it's still a great time. And that might get you questioning why, what is sort of the point of all this? So there's a couple big ones, but one of the big ones is that this kind of creates a universal compilation target for a polyglot feature that's safe, fast, and portable. That's a lot of jargon, but really what this allows for is writing in many different languages and bringing any of those languages, the code that you wrote in those languages to the web. Okay, JavaScript was the first language of the web. WebAssembly is a path to bringing other languages, older libraries, not having to rewrite stuff in JavaScript to browsers, right? And a really great talk, a really great blog post about this is Brendan Ike, who wrote on his blog the first introduction of WebAssembly back in 2015. Highly recommend reading this. It's really, really good. I'll drop all these links, and I'll also put a link to the slides, which have links in them after the talk's done. So why is it taking so long? It's another great question. It's taking a long time because there's a standardized effort. There's a standardization effort that is actually kind of unique because of who's involved. So if you're familiar with the browser wars that kind of happened in the 90s, if you know your internet history, there was quite a lot of back and forth about what should be included in JavaScript and what browsers should have what. And then you also got Flash and you got all these other standards. And after a long and arduous battle between some of these huge companies, it was decided that maybe it's better to work together on some of these things if it's going to be so ubiquitous like browsers are today. So with that in mind, the four major browser companies got together and they actually all sit together on the standardizing sort of committee that works on agreeing on new features and what should be added and what should be removed from WebAssembly as it gets built, as it gets standardized. And so that's a little bit different from something where you're just trying to get it to market as fast as possible. So instead of just relying on market pressure to drive things forward, these groups are really focused on getting it right and getting these things right. So it's kind of interesting in that way. And I think that a lot of these people in these groups have decided that web browsers, they're here to stay. So just like JavaScript has become more and more standardized, and it's basically, for the most part, implemented in a very similar fashion across all the major browsers, WebAssembly is kind of following the same path. So where does WebAssembly shine? Things that are computationally heavy, that are not highly IO bound, like input output bound, right? So some of these things you might have heard of. There's a really great opportunity that this company StackBlitz took advantage of, where you can run Node.js in your browser, but not with the runtime for JavaScript that exists in your browser. So they took Node.js, they compiled it to WebAssembly, and then you can run that in your browser, which is really fascinating. So it's like you have a completely online IDE that doesn't make calls to a remote host. It's it just makes calls within the WebAssembly sandbox itself, right? Kind of fascinating. Some other things. This is a great example from this guy Colin, who used TensorFlow JS, which is a port of the TensorFlow machine learning library, which actually is an older C++ library that's just wrapped in JavaScript, and it's running in WebAssembly. And this is a demo of him using computational vision to solve these Sudoku puzzles in real time. Very, very cool. Jupyter Notebooks, if you've done any Python or machine learning stuff, data oriented things, Jupyter Notebooks are really big. So the same thing applies here. You can run Python in the browser with WebAssembly. So you can have a Jupyter Notebook running, and you can run machine learning models without having to have a server doing them. Like I said, and if you've ever done this stuff, you'll understand that it's very high CPU bound, right? So if you ever run machine learning models on a cloud service, you have to typically get one that will allow you to max out the CPU the entire time, or have special sort of tailored environments for high CPU usage. Yeah, TensorFlow.js, mentioned that. Definitely check it out. Oh, there's some other interesting ones. A lot of crypto projects have realized that WebAssembly is a good alternative for doing peer-to-peer things, because it provides sort of a platform agnostic runtime for different things. And there's more and more and more. There's a lot of stuff here. So I definitely would recommend checking this out, made with webassembly.com. It's a really nice grouping that they keep adding to, of different examples of WebAssembly in real life. Okay. So places to start as a React developer. This is kind of the meat of it here, and we'll kind of get into how you would get started using WebAssembly in your JavaScript project and a React project. So when we think about WebAssembly, we mentioned that it is a virtualized CPU layer, right? And so just like we don't write assembly by hand on your machine at home, we typically don't write WebAssembly by hand, but you can, right? And so this is where this idea of the WebAssembly text format comes in. So this is basically a representation of the binary format that WebAssembly spits out. So here's an example. Let's see if I can pull this up. Right. Okay. Yeah. Okay. So we'll talk about this here. Right. Sources. So when you load a WebAssembly file into your browser, it's automatically represented like this. This is WAT, the WebAssembly text format, right? You can see, maybe if you're familiar with Lisp, it's kind of like S expressions. It's based on S expressions, actually, but it doesn't quite look like something you'd want to write by hand, but you definitely can, right? So there's a lot more detail in the MDN docs. In fact, the MDN docs are a really great place to start in general if you're trying to get involved with WebAssembly in your project. So I would check out WAT, and then I would also check out Assembly Script. Assembly Script was made with the specific intent of sort of being easier to come from a JS background and to sort of get into WebAssembly. So what they did is they took a TypeScript-like syntax and made a language that compiles first and foremost to WebAssembly, and that is sort of a, so it's not quite JavaScript, but it kind of looks like JavaScript, and it's a great way to sort of see like what you can do compiling right to WASM. So for example, here is TypeScript, right? And it looks like normal TypeScript. Okay, here's what it looks like when it's compiled to WebAssembly. This is the WebAssembly text format representation. And yeah, so highly recommend. Oh, and this example is actually, let me see if I can run this. This is the Mandelbrot set that, so it does a lot of computation. Let me see. Oh, I don't know if this still works. The demo gods. That's what happens. Okay, well, we'll have to come back to that. And then, of course, Rust. A lot of people know about Rust. People might have experimented with Rust. There's a lot of talk about that. One of the reasons that Rust gets talked about so much with the context of front end is because Rust has one of the best sort of ecosystems and support for WebAssembly right out of the box. So one of the things that makes that possible is this library called the WASM bindgen library. So getting data from the JavaScript side to the WebAssembly side and back is not quite the simplest thing right now. And to newcomers, it can be something that's kind of daunting. So one of the cool things that people in the Rust community have done is they built this library that allows you to take high-level types from JavaScript and use them in Rust and pass them back and forth without having to sort of do really complex type conversions. And then, yeah, so best practices, interfaces, and patterns. This is a sort of an interesting thing, and I put best here in quotes, not to be sarcastic, but to say that like it's a pretty new area. So what is best and what is considered standard practice is still developing, right? But there are a couple rules that you can follow and a couple trends that are actually pretty solid that I think that will sort of crystallize in the next few years. And one of them is loading things asynchronously. One of the cool things about WebAssembly is that you can, the way that it's implemented in browsers right now, is you can load asynchronously. You can make a network call. It can come across, it can stream to the client, and it can compile at the same time. So that's a pretty huge thing for larger modules. So instead of having to wait for the whole thing to download and then compile and run, it can stream the whole thing and then it can start compiling concurrently, right? So this is great because, let's see, because there's a lot of large WebAssembly modules from sort of legacy packages that can actually take quite a bit of time and resources to come across the network and then get started. So here's an example. Yeah, let's see. So this example, yeah, here you go, right here. So it's a pretty simple API, right? Like WebAssembly instantiate streaming, simple fetch requests, and then this is what happens once it resolves. So we'll talk a little bit more about some of the basic WebAssembly JavaScript API. I just realized I've been ignoring the chat. So if you do have questions along the way, feel free to drop in the chat. I'll try to make sure I'm keeping an eye on it. Yeah, so you want to reduce interop between JS and WebAssembly. So there is a cost between getting data to the WebAssembly module and from the WebAssembly module to whatever your host runtime is, which in this case, in the browser, it's JavaScript. So sending data or going between sort of the UI and the WebAssembly sandbox is expensive. And it's better if you can just get your data there, do the computation you need, and when you're done, send it back. So this is actually kind of, if you zoom out, this is a really good sort of illumination of why WebAssembly really doesn't have a place in UI development right now, because that cost is too high. There's really no benefit to, say, rewriting your whole app in Rust if there's a lot of complex UI things going on. There are these examples of companies that have taken certain pieces and rewritten them in Rust or ported an old C++ library or C library into whatever they are using with their UI. And one of the examples for that is one of the really famous ones now, especially with the recent acquisition, was Figma, right? So Figma used WebAssembly to port, I believe it was like shading libraries that were pretty high CPU bound. And they used these really complex older C++ applications or libraries to bring in, and it gave them like such a huge performance boost rather than doing it in JavaScript and having to find really optimized JavaScript along the way. So it's kind of cool. So there's quite a bit of opportunity to take older libraries and not have to reinvent the wheel just to get them to work in the browser. Some of these fun examples, like one of them is someone took Vim and they ported it to WASM, and so Vim is written in C, and they took it and you can run Vim in your browser, which is pretty cool. Like not feature complete, but pretty close, right? Another one is this command line tool JQ, which is it's a JSON parser on the command line, and it's really fast. And he took this, and you can use JQ in your browser. So Fernando, can you run WebAssembly outside a browser? Absolutely yes, and that's what I'm going to talk to about here soon. But that's an excellent question. So the answer is yes, and I'll tell you more about that in a second. So we'll keep going here. Okay. Whoops, stop doing that. Okay. Yeah, also check out that site that I mentioned, madewithwebassembly.com. Really fun site. Yeah, and then there's like other things that people have done, and that's basically like, okay, just take this old app that we have that would be insane to try to rewrite, right? If you've ever done systems programming or stuff with C or C++, like that can get so complicated in a different way than web apps are complicated. And to try to redo that in JavaScript, it would be like just another nightmare, right? And so a great example is if you've ever played around with FFmpeg. FFmpeg, I believe, is written in C++. And there is a great WebAssembly port of FFmpeg, which does it does a lot of stuff for image manipulation, and it does it in the browser. So you can definitely play around with this. It's really fun. But so instead of doing all this really high intense compute stuff on a server, you don't even need a server. You can just do it right in your browser, and it uses the resources of the client machine. So let's see. Yeah, Blazor is great. Yep, Blazor's a WebAssembly implementation for UI. Yes, that is right. And talk about Blazor more. There definitely are WebAssembly implementations for UI, and it's a little outside of the scope of this talk, but they what I was mentioning about how there's a cost to crossing the WASM boundary. They still use JavaScript, right? They still use JavaScript bindings to interact with the DOM. So it does make it easy to do things with WebAssembly, but Blazor is a really interesting one because you can see, if you load it up, you can see all these like DLL files and stuff that are coming through as if it's just like running on a Windows machine. So but as far as like UI development, there's not a lot that's there's not a lot that makes it that gives you huge advantages for writing more novel UIs. But what Blazor does do is that it allows you to bring in these .NET libraries that maybe are already written that would only run in some sort of Windows environment and run them in the browser. Yeah, it's pretty cool. I actually don't have a ton of experience with Blazor, but I've definitely played around with it. It's really interesting. Yeah, okay, so definitely if you're interested in this, more best practices, check out the MDN docs. The MDN WASM JS API is they have some great examples, tons of information, more than you probably even need to know to get started, but some very good simple examples and explanations, right? Cool. All right, what else we got here? Node. So cool thing about Node is that it's experimental right now, but Node has its own WebAssembly support. So you can run WebAssembly right out of the box with Node, which is nice because it allows you to do things like, and so we're outside of the browser here, right? But it allows you to do things like if you have a language in another library and you want to run it in your Node project, but you don't want to rewrite it in JavaScript or Node, this can be a good opportunity, a good option for that. Still a little tricky to do that, and we'll kind of talk about that here in a second. Dino, if anyone is familiar with Dino, so they also have excellent support for WebAssembly. You can compile it itself to WebAssembly, I believe. There's some cool isolation features that it uses. Really, really, really cool stuff there. And there are others. Nappy RS is a big one. This is like related to, this is using like Rust, makes it easier to use Rust things and things like Next.js. And also WASI, which we haven't touched on here, which is also a good topic for another post. But WASI is the WebAssembly System Interface, and this is a newer idea that's still developing, but actually maturing quite a bit, which is what allows you to do. Let's say you're writing something for WebAssembly. WebAssembly is like a sandbox wherever you are, and it doesn't let you do things like make a network call or access the file system, which in many cases is good, but sometimes you want to do those things. And so WebAssembly, the WebAssembly System Interface gives you a way to do that in a very scoped and controlled way. Okay, let's see. All right, the future. Let's see here. So the future, if I can restart my slideshow. Sorry, 1 second. Okay. Outside the browser, this is another talk. There is a sort of entire world with WebAssembly that's developing where people looked at what WebAssembly was in the browser a few years ago, and they said, it's interesting that we have this sort of contained environment that has near native performance where I can run code from any language or environment, and you can run them side by side with other modules, and they can't interact with each other, they can't talk to each other, and it's very small and it's very, very fast. And this is kind of what I refer to as like cloud infrastructure's penicillin discovery. Like it was like an accidental discovery of something that solved some problems that other technologies had also been trying to solve. Things like containers, VMs, serverless runtimes. And so some companies like Fastly, Cloudflare, they came up with sort of standalone WebAssembly runtimes where for serverless functions in particular, it became very attractive right away to, instead of having to spin up an entire VM or an entire container, spinning up a WebAssembly module was much faster, like orders of magnitude faster, much smaller, and much safer actually in certain ways. And so there's sort of a growing area there for server-side WebAssembly. And if you hear about server-side WebAssembly, that's kind of this space. And then WASI, like I was mentioning, this is kind of the WASM successor to POSIX, right? The portable operating system interface, which came out of Unix. And WASI is still under development, but it's also a way, like I was saying, to sort of in a scoped fashion, do things like make network calls, talk to the file system, things like that. Yep. Oh, yeah, this is another one. So if you've heard of Docker, if you've ever worked with Docker, this guy, Solomon, he came up with Docker back in the late 2000s, and he had this tweet that he said if WAS and WASI existed in 2008, we wouldn't have needed to create Docker. WebAssembly on the server is the future of computing. A standardized system interface was the missing link. So he's talking about WASI here. So some people are pretty excited about it. This is still pretty early in development, but basically it looks at this problem space and it says, hey, this could be a really good solution. So again, though, that's another talk because that's a sort of whole other set of things to get into. But in the browser, there's a lot of things still coming down the pipe, which is very, very interesting. So GC, garbage collection. So this is just a virtual CPU. It just executes binary in a specific space. So when you try to run something like Python or Ruby or even like Node, like I was talking about StackBlitz, took Node and then brought it over. So what you have to do is you have to bring the entire runtime. You have to bring the entire runtime to and download it and have it in the browser. So like it spins up its own JIT compiler, and then it has to deal with its own garbage collection. And so there are these new proposals coming down the pipe with the WebAssembly committee that kind of solve some of these problems in an abstract way. One of them is GC, is adding sort of an abstract garbage collection component to the WebAssembly spec. Then there's also interface types, which allow for higher level types. Right now, WebAssembly at the lowest level just understands numbers, floats and ints, 32 and 64. That's it. And interface types would allow things like, say, strings or like maps or objects to kind of be passed between these different runtimes a little bit more effortlessly. Then other things like SIMD, same instruction, multiple data for data intensive things, and then things like networking. So these things are coming down, and they will sort of change what is possible in the WebAssembly space. Okay, I think I am getting a little past my time, but I'm almost done, I promise. If you're curious about this, really great project is WASM Feature Detect. Okay, WASM Feature Detect is a small little library that allows you to just drop it in your client script, and then it tells you if there is support for this feature or if there's support for whatever feature, right? GC, multi-value, SIMD. There's a lot here, but this lets you, it tells you if the browser that you're running on has support for that thing. In fact, GC, garbage collection, you have to flip the flag in your browser, but there's optional support now as of like yesterday or 2 days ago for GC, which is pretty cool. Okay, last thing, this is where I work. We do a WebAssembly thing, and it's also usable in the browser. I just need to talk about this real fast. It's called the Scale Runtime. It's really cool. Highly recommend you check it out. So this is the same thing. This is what I've worked on a lot for the last 6 months, and it is basically a way that you can run any language. You can run code from any language in any other language, right? So I kind of jumbled that, but basically what it does is you can use a tool from language A in language B, and it's made possible with WebAssembly. And in some cases, the performance is better than it would even be on a native platform. Right now, we have support for Rust, Go, and TypeScript. That's pretty cool. So you could like have a project in TypeScript, and let's say you had a library or some middleware or some authentication thing that only exists with a Go library. No big deal. You just throw it in with Scale, and then in your TypeScript project, you can use that Go code, and you don't really have to do anything or think about how it works. So we've got more and more stuff coming down the pipe like that. Ruby, Python, Swift, Java will have support for all of these languages. So it's kind of like, one way we like to think about it is it's kind of like there will be no real need for new middleware. If you've ever written middleware, like if you've used like an SDK, it's like for like AWS or I don't know, LogRocket or like any of these things, sometimes you have to like make sure that there is JavaScript, a good JavaScript package that's up to date, or there is a good Go package. This kind of obviates all of that and just says, hey, if there's any package, you can just use it and it'll just always work. Sorry about that. And we really think that, so one of the things that's important to me and with this project and us, and I think in general, is that WebAssembly is just an implementation detail, right? For those of you who have used Docker here, right, when you run your container image, you don't really need to know what Docker is doing under the hood with Linux C groups, right, to understand how it's like restricting access to certain machine resources, right? That's all abstracted away. And so right now, WebAssembly is still developing so much that we really want to be able to help push the community by saying, like, it should just be an implementation detail. You don't need to know anything about WebAssembly to use it and to get the benefits from it. So yeah, check it out. Scale Runtime. We'll be doing a bigger announcement here soon about it, and I'll put all these links in the chat too. Yeah, so back to my tweet, obviously, and this is kind of where I wanted to come back to. It's like all these things, we didn't really touch on some of these things specifically, but there's a whole nother world of using WebAssembly on bare metal with IoT and embedded systems. It's a totally different thing, but it's really making some progress. Serverless infrastructure, blockchain, crypto. There's native on mobile. That's kind of a big one. There's this idea that, hey, if we can get it to compile to WebAssembly and you can have, say, a phone that runs WebAssembly, then why do we really need like an app store after that long? If it can just run in this sandbox way. I mean, that's maybe down the line, but it's still a possibility. So last quote I'll leave you with is this quote from Brendan Eich in 2015. He said, always bet on JS. And then he said, I look forward to adding and WASM into that line. No joke. So this is from the creator of JavaScript. It's himself. And so these two things are going to be sort of working hand in hand, and hopefully it'll just help to make the web better overall. More resources. I'll drop these slides on Twitter, and also I'll make sure that Bill has them. We're going to have another WebAssembly Chicago meetup in March. We're on Meetup or just WASM Chicago on Twitter, wherever. Just like look us up, wasmchicago.org. If you're really interested, you should check out a friend of mine's talk, Brian. He wrote the WebAssembly, the Definitive Guide. Excellent book for getting started with WebAssembly, deep dives and gets into some really practical examples. Also, he has an awesome talk, kind of doing a much better job than I'm doing in this talk about the entire sort of WebAssembly ecosystem, where it's going, where it's from, and check that out. It's on YouTube. I'll drop a link in here. We blog about WebAssembly a lot at our company, Loophole Labs. So there's a link to that. And if you're curious about language support for WebAssembly, a company called Fermyon has excellent sort of up-to-date information about which languages are supported and what's not supported, and what's missing, things like that. So I'd check that out too. Awesome WASM. I don't know, it almost rhymes, but it's a great GitHub repo with tons of WebAssembly resources there. I definitely recommend checking it out. And yeah, thank you. I kind of went over, hopefully not too bad. I wanted to say a huge thanks to Bill for organizing. Bill's been doing this a lot longer than me with this meetup, and I've only done WebAssembly Chicago for about a year, and it's a lot of work to organize a meetup like this. So thanks to him. And if you're curious to learn more, hit me up on Twitter. It's D_PHILLA, and I'll just be here like hanging out. So yeah, I guess if there are any questions, I don't want to intrude too much more on Kareem's time. So if there are other questions, feel free to just ask away now, or hit me up whenever. So thank you.